Welcome back to Basic Mathematics. In this video, we're going to be looking at problem solving with proportions. As I said in the last video, proportions are possibly the most powerful problem solving tool that mathematics can provide you. There are a number of situations in the world that we can discuss using the idea of a proportion. Proportional relationships are the most common that you see in any application in the world. Proportions are also incredibly forgiving. As we'll see in the first example, there are in fact 8 different ways that I could model the particular situation we'll be looking at using proportions, all of which will give me the exact same answer. As long as you are a little bit careful to make sure you don't get things too out of place, you'll be able to solve a problem using proportion without too much further issue. That said, let me get my head out of the way and let's dive into a problem. On a particular town map, 2 inches represents 7 miles. How long is a hiking trail represented by a 3.5-inch line? Let's take a look here. First of all, this sort of situation is very typical of the situations that will be modeled using a proportion. You have this relation. Every 2 inches on the map is 7 miles in the world. Given the number of inches on the map, you can use that to calculate the number of miles in the world using a scaling factor. That is the entire idea of a proportion. So once we've determined that we are going to model this situation using a proportion, we can kind of dive right in. A proportion is always going to be written as some fraction equals some other fraction. We have 3 values that we know: 2 inches, 7 miles, 3.5 inches. We can choose any of those to write down first. Let's write down 2 inches. It's the first number that shows up. Once we've made that choice, that is half of the possibilities taken into account, right? That 2 inches could have gone in any one of the 4 spots. Before we wrote down the first number, there were 8 different proportions that were all going to give us the same value. We've chosen that we're down to one of 2 proportions that will give us the same value. So let's take a look at the next number. The next number may or may not decide what is to come. The next number is 7 miles. The map scale relates 2 inches to 7 miles. So because these 2 numbers are directly related to each other, they need to be near each other in the proportion. We can choose to either put that 7 miles right here or right there. Both of those are valid options. The way that I think of the ratio, the rate, inches on the map to miles in the world. So I think of that as a rate, which makes me want to put 7 miles right there. Then I look at the next number, 3.5 inches. And I need to determine, is 3.5 inches more closely related to 2 inches or more closely related to 7 miles? It's only going to be related to one of the two. This spot is related to 2 inches. This spot is related to 7 miles. Well, 3.5 inches is a measurement on the map. 2 inches is also a measurement on the map. So my numerator needs to be just measurements on the map. I know that 3.5 inches needs to go there. That leaves me one more space. And I look back at the problem and I identify what is it that we're trying to solve for. We're asking how long is the hiking trail? Well, the hiking trail is a measurement in the real world. 7 miles is a measurement in the real world. And the 3.5 inches is the depiction of the hiking trail. So because they are both in the world, 7 miles and our unknown are related. Because they are both talking about the hiking trail, 3.5 inches and our unknown are related. That's your double check. Before you fill in the last spot in a proportion, make sure that it's related to the thing above or below it and the thing to the left or right of it. You can set this proportion up, as I said, in 8 different ways. I'm going to quickly go through and write down all 7 of the other ones before I solve this one, which is the great thing about proportions. Is also the hard thing about learning proportions, because the way I set up a proportion and the way you set up a proportion might not be the same, but they will still satisfy the problem. Which am I missing up? All right, so there are the 8 other, or the 7 other options that will all give me the same result when I try to set up the proportion. you only need one. It doesn't matter which one you choose. And the reason that these all will work is if you take the next step. The next step in solving a proportion is to use the cross product test. No matter which of these proportions you set up, you will notice that it turns into 2 times x is equal to 7 times 3.5. Or 7 times 3.5 is equal to 2 times x. From there, we multiply 7 times 3.5 is 24.5. And if 2 times x is equal to 24.5, then the inverse of multiplication is division. X itself must be 24.5 divided by 2. I get in this case that my unknown x is 12.25. That's the idea of problem solving with proportions. Taking the time to think about how the numbers in the problem relate to each other, recognizing that the situation you are looking at is one of scaling, so proportions are going to be the tool to use, and then starting to write down numbers in a way that exemplifies their relationship. And you have 8 different options that work. There are a couple of other options. All told, there are 24 different proportions that you could write using the same set of numbers. Only 8 of them work. So you do have to take some care to make sure that you set up a valid proportion, but you do have a lot of valid options. So it does make your life a little bit easier in that regard. Take a look at the practice problems, the assignment on solving proportions, see where you can get to with those. And I'll see you next week.